Hello, it's Eugen. This is the second part of the video devoted to electroshock devices, stun guns, tasers, etc. In the previous part, we found out the parameters which the ESDs should meet, and now we will examine the main schemes of ESDs, including industrial ones, and what effect they have on an object of application. Let's go on. Let's begin with literature. The first is the book of Koretsky-Silnikov. I mentioned it in a previous part. This is a Russian forum, Guns.ru, dedicated to different guns, and this branch is devoted especially for ESDs. Two sites of Russian enthusiasts. The second one is from Oleg Nemtyshkin. As far as I know, he is working now in USA. Electroshok. This site contains a lot of constructions of multiplier-based shockers. We will talk later what is it. And many shocker makers attitude with some suspicion to this site, but there are a lot of interesting constructions. ESD Inside Net, it's a site from Lamazoid. It is inactive now, but can be found in archive. Some patents, one from US and two Russian patents. And the last one is analysis, comparative test of two stun guns, the Taser and Stinger. A lot of useful information can be found there. Okay, this is the requirements for ESDs, which we found out in a previous video. ESDs must provide an average output current of unit or tens of milliamperes and peak voltage in order of several tens of kilovolts, which is necessary to wrap some protective clothes on layers under the skin of our object. ESDs should generate output signals in the form of pulses, which frequency of several tens to several hundred Hertz, and duration on order of units of tens or of microseconds. Also, it must be portable, safe for both the subject and object of application. Otherwise, we should go to jail. It should also have some psychological effect, crackling, loud sparks and bright sparks, because it can help to help prevent physical contact with attacking person. And the last point is a quote from Russian standard, which said the minimal distance between working, maximum distance between working electrodes is 40 millimeters, and somehow the distance between contacts which are ejected by means of spring or pneumatically, it's tasers. It is another limit. There is another limit of 30 millimeters, 300 millimeters. Why is it different? I don't know, but the reason for such limits are obvious, because when we have a long distance of current passing through human's body, it can produce fibrillation. Okay. A question which is very frequently asked by novices and beginners: why not to take one stage converter with a massive secondary winding connected to some power supply, for example 9-volt batteries, and have some sparks on output. And why can't we try to use it as a shocker? Some developers do they with, for example, automobile ignition coil, and are very surprised why the sparks are so short on the output. Okay, let's do some simple calculation. If we have, for example, 5 turns in primary winding to obtain little inductance in it, and our source is 9 volt, then to obtain 90 kilovolts, in reality it will be much smaller because of some parasitic effects, low conductance, mutual conductance between this winding. So we must ensure transformation coefficient of about 10,000, and accordingly the number of turns in the secondary winding should be, you can see this number, 50,000 turns. It's a huge number which cannot be achieved in a portable device, because we should also isolate it very safely, and the core should be isolated, and this number, it can be put in your pocket. Device with such number of turns cannot be portable, and besides, the output pulses will be too short for some physical reasons. So such an easy way cannot be, unfortunately, we cannot utilize it. What is the basic ESD circuit? It contains power supply, then high frequency converter, which boosts our input voltage to a level of some units of kilovolts. So we have some intermediate transformation, and the output high voltage block, which boosts the voltage from 1 or 2 kilovolt to some tens of kilovolts, which is necessary for us. And the main theme of discussions, the main theme of patents in shockers is this high voltage block, how it is arranged. And this is made in two basic circuits. One of them is multiplier based, as voltage multiplier is utilized as a booster, and another one is transformer based. When some capacitor is charged from intermediate converter, then some connectors, some switch is activated. In most cases it is a simple gas spark gap, and some high voltage transformer in secondary winding, of which we obtain our AM voltage. Now we will examine these two schemes, but at first we should learn how this high frequency intermediate converter is arranged. There are a lot of schemes in it. It can be 1 or 2 cycles, 2 cycle schemes, and often they are made on discrete components to reduce its costs. Let's now see, this is, for example, the simplest one of the simplest example, blocking generator on one bipolar transistor. This is the bias winding. No, this is power winding, and this is feedback bias winding. There can be also 2 cycle generators based on the same bipolar transistors or MOSFETs. There are some more efficient. Royer generator based on 2 transistors connected with some complicated feedback circuit. There are also a number of schemes based on simple ICs, for example, 555 generator, UC 3845. I examined such a circuit in my converter series, and this is the peak of construction thought. Very worked out scheme based on especially LT3750 high voltage converter IC. Very complicated and very high engineered scheme. It contains also current limit. It also tracks the voltage on secondary to find its 0 points, etc, etc. So this is the most complicated scheme I found on dedicated to shockers especially. Okay, let us examine the main schemes of high voltage blocks. The first of them is multiplier based ESDs. Multipliers are very widely used in different spheres, and they also can be bought in module form. For example, I found in AliExpress 8-stage multipliers or 24-stage, as it is depicted here. What are their advantages? They are simple. The most complicated multiplier is much more simple to make than transformer one. Why is it so? It's clear from these pictures. In a multiplier is a sort of some prolonged structure where high voltage is generated between these points, from between its input and output point. So this is applied to such a long distance, and they are frequently not even molded in epoxy, and only PCB, clear PCBs are left, and they work pretty well. And for comparison, here is a structure of layered high voltage transformer. As we can see, high voltage is applied to the points of from beginning to the end of high voltage winding, and this path is much shorter than this one. So very serious problems with isolation take place. Okay, another point is that the multiplier based modules have higher efficiency than transformer ones. When properly designed with a push-pull converter with a choke, high-speed diodes in HV rectification stage, for example. These are some examples which can be found in this forum. The theoretical efficiency in such case can reach even 100%, because we have no additional elements between our energy source, which is high voltage capacitance, and our load. Of course, it is not the case in reality, but potentially it can be with unity efficiency. What are disadvantages of multiplier circuits? As the input current direction is inversed, so we must at first charge some capacitance and then discharge another one. So two-cycle generator is needed. It may be on push-pull scheme or bridge scheme or half bridge, or the most popular is ZVS driver. And also we should equip it with a choke to smooth current peaks in an input stage. Okay, after we turn off our shocker, the capacitance, its output capacitors can preserve some charge, and you can get an unintended electric shock. In such worked out models, there are some resistors, discharge resistors, set in between the high voltage points of multiplier, but we cannot guarantee that it is there. Okay. The main disadvantage of multiplier shockers is their form of their output pulses. They are very short, units of microseconds. I was not lazy. I modeled some multiplier stage with powered with ZVS driver, and this traces indicates voltage on our load. It's 1 kilo ohm load. According to our previous video, it is equivalent to the load of human's body. And you can see that the pulse, when we this switch is closed, it means that discharge takes place. You can see that the pulse is very short. Its half width is only maybe 1 microsecond or less. Why is it so? It's clear because these capacitance in high voltage stage are on order of units of nanofarads. It cannot be larger because it will not be compact. So this is the disadvantage. We cannot do with it anything. Okay, and another conjunction disadvantage is that multiplier abruptly loses its efficiency when it is constantly contacted with load. This is pulses of our load in logarithmic scale. Logarithmic scale is voltage here. This is the input pulse, and then we have a series of pulses from the output winding of our intermediate transformer, because it is directly connected to the load through such a ladder of capacitors. So our load sees only pulses, frequency pulses of our converter. It can also be stop its generation in such conditions. It is not a rare case, but even if it generates, it produces high frequency pulses according to the ZVS resonance. It may be units or tens of kilohertz, and we saw in a previous part that such frequencies are inefficient. They produce only heat in human's body, and which goes to such shocks, such burned places, and the aggressor feels a lot of pain, but he also preserves his ability to make his aggression. So it's not stunner, it's only a pain generator, so to say. Let's go to transformer based ESDs. This is the main scheme of industrially performed shockers. Their advantage is the simplicity of high frequency converter. The simplest single cycle converters can be used, for example, based on blocking generators with one transistor. They are reliable under any load or without load, and when properly designed, safe for the owner, because the high voltage and low voltage, intermediate voltage parts are galvanically isolated one from another. What are disadvantages? Complicated construction of high voltage transformer. We spoke about it, but now I can show you some pictures. The transformer must be very well isolated. Frequently it is molded with epoxy or paraffin, and it is not a simple deal to make such a transformer. Also, this transformer has low efficiency due to poor inductive coupling of the windings and the saturation of the core of the transformer. For an example, I wrote here some calculations for a capacitor of 0.1 microfarad, initial voltage of 1000 volts, and pulse duration of 20 microseconds is such a mean value of this tau. We have power of 2.5 kilowatts in the pulse. So any transformer, portable transformer, will be saturated under such conditions. This is the graphs of power build up on a load in comparison with what it is pumped into, but it's from a book of Silnikov, and the disadvantage of this graph that we don't know the initial power of capacitor, so it's only comparative graphs. And this is the construction of another construction of layered transformer. It is clearly shown here that the secondary winding is here, must be safely isolated as from primary one and also from the core, and it is not simple to do. Here is my model, which I built from transformer section, output section, and this is efficiency of energy conduction to the load from the capacitor, high voltage, intermediate voltage capacitor. You can see that when mutual inductance decreases, also the efficiency falls very rapidly. You can also see that even in mutual inductance equal to 1, the efficiency reaches only a quarter. It's because of parasitic elements in first and second circuits that are unavoidable. For example, series resistance of this capacitor. And this is the form of pulses, output pulses of this transformer. How can we improve the efficiency of our ESD? The main way is, which is utilized in, for example, Taser constructions and depicted in many patents, is to set a second capacitor seriously with the secondary winding. This capacitor is charged from the same voltage source as ignition capacitor, and is discharged when the ionizing channel is formed through the load. This leads to total efficiency upgrade of ESD, because we for this capacitor we don't have interstage of transformer with its low efficiency, and also we have elongation of damaging pulses. For example, this is the pulse sequence of Russian Thunder shocker with only transformer output, and this is from Stinger shocker, which is from the or Taser, I don't remember, in the 10th point of literature in the first slide. You can see that this is this process takes only about 20 microseconds to this, with all this oscillations. And now this have a prolonged part with a duration of more than 100 microseconds. So it's much more. This is much more efficient on a human's body. This is only a disadvantage in this circuit, that we should install an additional spark gap, because when these contacts are in constant contact with the human's body, it cannot be charged to its aim voltage. There are also a lot of designs of ESDs. We should say about this. This is the most popular pocket ESD, stun gun with some safe switch. It prevents from unintended discharge in your pocket when you can press this button, for example, and take a discharge on your leg. This is a distant acting shocker. For example, Taser is based on such a construction, and it contains two probes which are shot on a distance and hanged to clothes of aggressor. And high voltage generated inside this device is conducted to these probes by thin wires. This is shocker for police, like for a heat action also. And this is another model. Okay, let's finish for today. Here are conclusions. In practice, ESDs are implemented in the form of circuit with a two-stage voltage conversion from power supply to units of kilovolts, then to several tens of kilovolts. The most effective design of the high voltage part of the ESD is a pulse transformer. And to increase its efficiency, we can add some measures, for example, in additional capacity in serial with the secondary winding. On this principle are based Taser and so-called Electroshok in Russian language. Okay, that's all for today. Goodbye. It was Eugen.